y'all. It's that time again. It's Math with Mrs. Peters, the crazy cat lady of Hiram High School. Today's topic, rational equations. Now, we've been playing around with rational expressions, and now I'm going to throw an equal sign in them. Guess what? They all work just the same. So, here's my first one. Here's my rational equation. What I need to do is I need to find my least common denominator. Okay? Now, we've talked about this before. Least common denominator. Okay? This would be 3r squared. I'm going to make equivalent fractions. All right, so that means I'm going to take 1 over 3r and 1 over 3r squared and 1 over r, and I'm going to create them so that they have the same denominator, which would be 3r squared. So, what do I have to do to 3r to make it 3r squared? I have to multiply it by r, so I'm going to do top and bottom. What do I do to 1 over 3? What do I do to 3r squared here to make it? I'm going to multiply by 1. What do I have to do to r to make it turn into 3r squared? I'm going to have to multiply by 3r. Now, I'm going to go ahead and do that multiplication. So, the top one, 1 times r is r. 1 times 1 is 1. 1 times 3r is 3r. Oh, all right. Now, I'm going to use the magic of Mrs. Peters' wonderful, lovely board, and I'm going to ungroup so that I can grab things and regroup. All right, because I'm lazy, I'm going to take these little guys and I'm going to clone them. Okay. Now notice, I put them right below the equations that they matched up to. I think I'm going to change their colors. Yeah. Nah, I won't. Okay, I'm going to put plus between them and an equal sign. Now, they are all over the same denominator, which means I can use the same thing that I did in rational expressions and write everything over a common denominator. So I get r plus 1 equals 3r. The best part of this, guys, is that now I have an equation that I already know how to solve. All I have to do is deal with what's going on top of the equation. All this right here. See if I can get it to group. And I'm going to clone it. And we'll bring it down. Now, all we have to do is we have to solve this little simple two-step equation. Right? Way back when, in the history of mathematics, you learned how to solve an equation like this. I'm going to subtract r from both sides. So I get 1 equals 2r. Divide both sides by 2. And I get 1/2 is equal to r. What I do have to make sure is that my answer, whatever this is here, does not make any denominator within my equation go to 0. So what I'm asking is, does r equal to 1/2 make, and I'm talking about these guys here, does it make my denominator turn to 0? Does it make 3r equal 0? Does it make 3r squared equal 0? Does it make r equal 0? What I'm going to do is I'm going to substitute in 1/2. So this is 3 times 1/2. Well, that doesn't equal 0. That equals 3/2. Or 3 times 1/2 squared. Well, that would be 3 over 4. Okay, well, that doesn't equal 0. And definitely 1/2 does not equal 0. So that means this is a good solution. So that's the first problem. Let's talk about one that requires a little bit more when it comes to the algebra part of it, which is finding least common denominator. we do it all the same exact way. Okay, my least common denominator here is 3 times n plus 1. Okay, that means I've got to make 5n plus 25 over 3n plus 1. Excuse me, 3n plus 3. What do I multiply it by to get 3n plus 1? Okay. Oh, I don't think I like this. Anyway, n minus 6 over n plus 1. What do I multiply it by to get 3 times n plus 1? And what do I multiply 1 over 3n plus 1 times what? Gives me 3n plus 1. Now, what I want you to notice is that this one here, I didn't bother to factor, but this one here I didn't. This is the same thing as when we are dealing with rational expressions, right? So that it's real important if we go ahead and factor our denominators so that we can find the least common denominator. So for this one, I don't need to do anything. For this one, I don't need to do anything. But the middle one, I need to multiply both sides by 3. Okay, so this becomes 5n plus 25. This one becomes 3n plus 18. And this one is still 1. Using the lovely technology, we get to now, we'll put in my new fractions, 5n plus 25 over 3n plus 1 equals 3n plus 18 over 3n plus 1 plus 1 over 3n plus 1. Again, it's a really bad line. So this becomes 5n plus 25 equals 3n plus 18 plus 1 over 3n plus 1. That means all I need to solve is this. 5n plus 25 equals 3n plus 17. Oh, sorry, I went a little too far, too fast. 18 plus 1. Is there a subtraction sign running around here somewhere? Nope. Yes, there is. There's a subtraction sign right there. I knew there was. That means this is a subtraction sign. Sorry, math teachers do make mistakes. Now, let's solve this little equation. All right, so this is 5n plus 25 equals 3n minus 17. Okay, subtract 3n from both sides gives me 2n plus 25 equals negative 17. All right, subtract 25 from both sides, I get 2n equals negative 42, which means n is equal to negative 21. Again, we have to check to make sure that answer does not make any of my denominators turn into 0, because you can't have denominators equaling 0. So let's go back up here. What are my denominators? 3n plus 3 and n plus 1. So we're going to check our denominators. 3n plus 3 and n plus 1. So I don't know if they equal 0. So I'm going to stick 21 in here. 3 times negative 21 plus 3. Does it equal 0? No, it doesn't. Okay? And negative 21 plus 1 is negative 20. That doesn't equal 0. So this is a good value to have for n. That's the end of the lesson. We will talk more about what we call excluded values, or those numbers that you can't have in the denominator. And that's all for today's lesson. If you have any questions, bring them to tutoring. Be happy to answer them. Talk to you later. Bye.